Looking at 6.6, properties of kites, trapezoids, and then what we have called isosceles trapezoids is a little more specific scenario. A kite is a quadrilateral with exactly two pairs of congruent consecutive sides. So notice they're consecutive to each other. If you think about what a kite shape looks like, one that you fly in the sky. Okay, that example there. In this case, the top two sides are the same length and the bottom two sides are the same length. Couple of properties. It says if a quadrilateral is a kite, then its diagonals are perpendicular. Again, notice more perpendicular diagonals. Very important. If a quadrilateral is a kite, then exactly one pair of opposite angles are congruent. So these angles opposite here between the sides, so notice one tick mark, two tick marks, one tick mark, two tick marks, those are congruent to each other. Angle A and angle C are not congruent to each other. Now, an important characteristic is AC, this diagonal, is an angle bisector. It splits A and C in half. BD is not an angle bisector, so it's something to keep in mind when thinking about kites. Problem-solving application with kites. Notice we've got some segments up there. We have right triangles. When you have right triangles, ladies and gentlemen, you can use Pythagorean theorem, okay, as they bring down into here. Just to let you know, there is a good test question of the Pythagorean theorem. That is what needs to be used when solving for missing segments on a kite. As well as our additional plug and chug. Given a couple of angles, you can therefore find, we have triangles here, so they add up to 180 degrees. You can therefore find missing segment or missing angle measurements. These would be a couple practice problems to possibly look over on page 441. If we need to do an additional problem on this, please reach out and let me know. Looking at trapezoid, okay, we are most specific with what we would call an isosceles trapezoid. That's kind of the, if you think about the shapes back in the day you used to play with, we see isosceles trapezoids. It starts out here with kites, or I'm sorry, regular trapezoids. Look at the base angles, a couple of bases, couple of legs. If a quadrilateral is an isosceles trapezoid, then each pair of these base angles are congruent. If a trapezoid has one pair of congruent base angles, then the trapezoid is isosceles. Look at your tick marks, okay, and notice your diagonals are congruent to each other as well, AC and BD. Okay, so very important, making sure you're paying attention, building off of parallelograms. It all talks about the same thing, talks about opposite sides being congruent or parallel, angles are congruent or supplementary, diagonals. Diagonals are a good sign as to what type of shape you're dealing with. And then you have using properties of isosceles trapezoids. Again, it walks you through it, guys. Okay, take your time, do a little bit of reading. Yeah, I understand it's tricky teaching yourself, but the notes are there for you in the text as well as on Google Drive with my notes. Okay, we can then apply some conditions. We know that these base angles are congruent here. Set them equal and solve. So on and so forth. Same thing with this check it out problem down here. Set them equal to each other and solve for your x variable. One unique thing about the mid-segments of any trapezoid is, if you think about middle, okay, for example, if BC is 10 and AD is 20, the middle of 10 and 20 must be 15. That's exactly how it works. Okay, and they do give you a little bit of a formula. XY equals 1/2 BC plus AD, so 10, 15, 20. The trickier problems are like example 5 here. If they provide you the middle and the long segments, think of the Frogger method. We jump down 7, we jump down 7 more. Therefore, it must be 24 units, which is answered in the work there along the side. Okay, and then we get into some of our practice problems, looking at the practice document. A lot of fill in the blank, a lot of the superficial problems we're covering here on the top layer. Next week on your assessments, okay, because that'll be what you focus on. You'll be able to dive in a little bit more on some of these calculations. Okay, you'll have your notes available to you as well. So making sure you have the base layer is what we need now, and then we'll be able to dive into some more next week. Thank you.